Hello, 6th grade math students. This is Chapter 5.2, Part 2, More Real-World Problems with Rates and Unit Rates. In Lesson 5.1, we learned to calculate speed, given distance and time. Today we'll learn to find distance, given speed and time. Let's say that Mr. Anthony drives his truck at a speed of 45 kilometers per hour. At this speed, how far does he travel in 2 hours? Let's begin this problem by figuring out how to use the formula we know, speed equals distance divided by time, to calculate a distance when we know the speed and the time. So we want to rewrite this formula to be distance equals something. Let's take a look at our formula here. Speed equals distance divided by time. How would we isolate the d, or the distance? The first step will be to get rid of that t, correct? This really is the same as d times 1 over t. So we can isolate that t, or get rid of that t, by multiplying both sides by t over 1. Okay? Let me clean up some of this mess here so you can see what I'm doing. Okay, let's start fresh here. So speed equals distance over time. To get rid of this t, we're going to multiply both sides by t over 1. To get time times speed equals distance. So if we know the speed and we know the time, we multiply time times speed to find our distance. Now that we figured that out, let's go back and figure out how far Mr. Anthony is going to drive in his truck. So the problem was, Mr. Anthony drives his truck at a speed of 45 kilometers per hour. How far does he travel in 2 hours? Well, our formula was that distance equals speed times time. So let's enter what we know. Distance equals 45 kilometers per hour times 2 hours. So his distance is 90 miles. The hours actually cancel one another out because this hour is in the numerator, this is in the denominator, and they cancel one another out. So if he travels 90 miles in 2 hours, how far does Mr. Anthony travel in 5 hours? Well, once again, our distance will equal 45 kilometers per hour times 5 hours. So 45 times 5 is 225 kilometers. Hey, I just realized up here I wrote miles, and I should have written kilometers. Sorry about that. So in 5 hours, Mr. Anthony's going to drive 225 kilometers. Let's work through a similar problem so I can show you 2 different ways that you can approach it. A racing car can travel at a speed of 175 kilometers per hour. How far can the racing car travel in 3 hours? All right, let me show you the first method that you could use. And this looks very similar to the rate and the ratio technique that we've been using in the last couple of chapters. We'll set this up as 1 hour equals 175 kilometers. So now we'll have 3 hours equaling 3 times 175 kilometers. So we'll travel 525 kilometers. This basically reverses the technique that we always used before to reduce to single units, except this time we're starting with our single unit and then multiplying to get the larger group. Typically, we were reducing down to a single unit instead. The second method is to simply use the formula. Distance equals speed times time. So once again, we'll plug in what we know. Distance equals 175 kilometers per hour times 3 hours equals 525 kilometers. See how the hours actually cancel one another out if you think of these as multiplying fractions? Try practice problem 5 on your own. The problem walks you through both methods. You can either use method 1 or method 2 that uses the formula. Doesn't matter which, as long as you show me your work and I can understand your thinking. Now we've learned to find speed when we know the distance and the time. And we've also learned to find the distance if we know the time and the speed. So guess what? You're correct. We're going to find the time given the distance and the speed. And here's the problem we'll work with. Lucas ran round a field at a speed of 8 meters per second. So 8 meters per second. How long did he take to run a distance of 96 meters? Let's work through method 1. In method 1, we know that 8 meters equals 1 second. We want to know how long it takes him to go 96 meters. So we're going to take 96 and divide it by 8. Do you see why? That'll give us the number of seconds it takes him to travel those 96 meters. So 96 divided by 8 is 12. So it took Lucas 12 seconds to run 96 meters. Now let's try method 2, which uses the formula. Once again, we're using that formula, speed equals distance divided by time, and we're rearranging the elements to solve for t. In this case, we rewrite it as t equals distance divided by speed. Can you see how that relationship might work? Okay, now let's plug in what we know. We're solving for time equals distance, 96 meters, divided by speed, 8 meters per second. So our answer becomes time equals 12 seconds. Now try practice problem number 6 on your own. Once again, the picture on the screen will walk you through both methods. So it'll walk you through method 1 or method 2 using the formula. You can use whichever one works best for your brain to solve the time it takes for Mr. Thomas to ride his motorcycle from city X to city Y. Good luck. Press pause while you work. And when you come back, we have one last idea for chapter 5.2. The last concept for this chapter is finding the average speed. So the speed that an object is traveling at over a distance may not be the same all the time. For example, you might be riding your bicycle and you might speed up or slow down as you travel between 2 points over a given amount of time. So you can use an average speed to describe how fast the bicycle is traveling overall. So let's look at an example. Post A and post B are 9 meters apart. Post B and post C are 21 meters apart. A bicycle travels from post A to post B in 2 seconds. Then it travels from post B to post C in 3 seconds. Find the average speed of the bicycle for the distance from post A to post C. So the speed between post A and post B is obviously different than the speed between post B and post C, because the distance between B and C is significantly larger than the distance between A and B, but it only takes 1 second longer to get there. So in order to come up with an average time, we need to compare the distances and the speeds and come up with some sort of mean or average speed. So average speed has a formula, and it is average speed equals the total distance divided by the total time. So let's plug in what we know and solve for this problem. The average speed is going to equal our total distance. So 9 meters plus 21 meters. Now, we'll divide that by our total time, which is 2 seconds plus 3 seconds. When we work this through, we come up with 30 meters over 5 seconds, or an average speed of 6 meters per second. Okay, folks, here's practice problem 7. It's going to ask you to find an average speed for the distance traveled between town P and Q, and then from town Q to town R. Use exactly the same technique as we used in the previous problem, calculating the average speed of the bike ride. The problem on your screen walks you through every individual step. Make sure you follow them because it'll really help you understand how this problem works. Press pause while you work. There's one final practice problem after this, and then we'll be wrapping up with 5.2 Part 2. And here's our final problem for this particular lesson. If Celia is running around a 400-meter track twice, and she's running it at 2 different speeds, we're going to find her average speed. Once again, all of the steps are lined up for you here so that you can see exactly what you need to do to solve the problem. I'll see you all in class tomorrow for more practice with real-world problems using rates. Have a great night.